This is Chloe, Lauren, and Nick, and we're proposing a stepwise mechanism for the following reaction.
In our reaction, we are given THF and HBr with heat added in. The first step of our reaction will involve a proton transfer from the HBr to the oxygen. This will happen via a lone pair from the oxygen plucking off the hydrogen, and the bond that was connecting the HBr, those electrons will be donated to the bromine. In this, we will create the THF molecule that will have a positive charge and a bromine molecule that will have a negative charge. The next step in our reaction will be the ring opening of the THF that does now have a positive charge. First, the bromine will attack the carbon that is adjacent to the OH. In this case, it doesn't matter which carbon it attacks because they're both equally substituted, but in some cases it does matter because the bromine would want to attack the weaker bond in order to form the more substituted carbon. This will allow the electrons that were bonding together with oxygen and that carbon to donate to the oxygen, and it will create an open ring with Br on the end and oxygen with an H connected to it on the other side. This was via an SN2 reaction. Oxygen acted as the leaving group, and bromine would be considered the nucleophile. Our next step would be a proton transfer in order to make oxygen and the hydrogen into a good leaving group. We know that we have as much HBr as we need to finish out the reaction because it doesn't specify any stoichiometry at the beginning or how much we had. So in this reaction, the HBr will give up a proton via proton transfer to the oxygen, and then you will end up with this molecule. And a negative bromine. And the OH2 now has a positive charge, therefore it is a good leaving group, and we know that this will precede an SN2 reaction where the bromine will attack the carbon adjacent to the OH positive, and then this will leave, forming what our intended product is the bromine, both on the ends, plus water. We know that there's no stereochemistry because you started achiral and you finished achiral. And that is it. In general, you would need 2 equivalents of HBr, and we can see that through the following reaction. And this is similar to the hydroboration oxidation where you use THF and have a ring opening. And that's it. I hope you guys learned a lot.
I'm sure.
And there we are.